Hi guys, I'd like to show you the details of my wheel knuckles, also known as steering knuckles, for the new prototype trike. Here they are. Now over here, this is the previous one that was used on prototype number 1, and if you can see that piece going out there, that's where the wheel mounts, and you can see the hinges that go to the steering arms, top and bottom. This has been heavily modified, so that's why it looks pretty awful. And you can see the mounting points for the brake calipers, and at the back, that's for the steering linkages. Now, one thing you'll notice about this is that that central column is inclined at a slight angle off vertical. So if you take that shaft where the wheel mounts, if that is horizontal, then that central, what they call the kingpin, is inclined away from the vertical. But it's only inclined away about 6.5 degrees in this case, which is theoretically not optimum. In theory, that kingpin angle is supposed to, if you drew a straight line, it's supposed to go right down and meet where the wheel hits the ground, the center of where the wheel hits the ground. But that requires about angle of about 13 degrees in my case. And I was going to increase the angle in the new prototype, but then I ran into problems because if I increase the angle, more like bigger angle, because it's a tilting trike, at the extreme tilt, the top of the shock absorber was hitting the top swing arm rather was hitting the shock absorber, and there were other steering geometry problems. So I decided to stay with 6.5 degrees because the handling was okay on the first prototype. And I came up with a simpler design, what I thought was a simpler design, and that's this here. Now what we have is, I'm just showing one of these here, just use some square tube and drilled a hole through it, and that's where the shaft will go for mounting the wheel, and that'll just be welded on. That's pretty simple. And then this here will be welded on there, and this becomes the linkage for the steering. On the other side, another little piece welded on, that little piece just here, and that's for the brake calipers. Now at the top there, there's a little bit of a problem up the top. When I was originally thinking it was going to be a 13-degree angle, no problem, I could weld another little bit of square tube on with holes. But when I went back to 6.5 degrees, it meant that the heim joints, that's these here, heim joints, they were too far in. So in other words, they were cutting into where I had to cut into the square tube. And the only way I could think to do that properly was to just have two separate little pieces like that will just be welded on. Get the perspective right on this. There we go. I'll weld those on. And therefore the heim joint can go in the middle. It seems pretty straightforward. One problem is though that this square tube that I'm using is only a 2mm wall thickness, which is a little bit too weak, I think. So I'm probably going to just weld some extra plating on either side to strengthen that, especially that part there, because of the forces that it will be subjected to. So that's a finishing off detail to strengthen it. But other than that, it seems okay. Now these heim joints, if I can just go and fetch it for you. One of the problems with the heim joint is that it's got vertical movement okay, but it has very limited sideways rotation. To get around that problem, we have these little things, which are very special little spacers. And although this is a 10mm diameter hole, intended for a 10mm shaft, what this does is it cuts it down, so we use an 8mm shaft instead. But it's shaped in such a way that the heim joint can turn a little bit more sideways than it would normally be able to. So instead of just using just spacers, we use these special ones. So they will be going top and bottom. if I didn't use these special little spacers, then I'd have trouble with getting the turning circle, turning around corners. But as it is, I can get just enough to turn nicely around a corner. So that's working out well. Now we'll see how it goes. I'll do another video. Well, I'll probably attach the second part of a video to this same one, just showing it after it's been welded together. But it looks like a fairly simple design, although I'm finding that the devil is in the details. And my welding is not very good, so we'll see how that goes as well. I will report back. Okay, signing off. This is the second part of the wheel knuckle construction. I have welded all the pieces together and added some reinforcing. It does look a little bit ugly. My welding is not very good, but it is quite strong. These are the little reinforcing pieces, 3mm thick on both sides there, on the end and underneath, and also on the top here, another little 3mm plate. So the whole thing is looking all right. The next step will be to insert the steel rod, which will be for the wheel. So that will go into here. Okay. And this is a 16mm outside diameter rod. Little spacer. And a washer, and then finally this is the adapter for the wheel. It is a mountain bike wheel with a 20mm diameter through hole. So that's what this is for. Now this over here, this is the mounting for the brake calipers. I could have moved it back a little bit. At the moment I welded at 3mm in from this surface. If I wanted to get the wheel just a little bit closer, I could have moved that back a bit more. It just needs to be enough room for the brake calipers have to bolt onto that, and I will need to make an adapter plate because that's didn't quite get that right. So there will be a little adapter plate for the brake calipers. So that's how it's looking. Okay. The next step will be to weld. So this will have welding on both sides to hold it firmly in place. One precaution is that this slides on very nicely. These two pieces were great. This is stainless steel, 16mm outside diameter, a little hole in the middle for putting in a thread so I can put a bolt on the end for holding the wheel on. This is 16mm inside diameter and 20mm outside diameter, which happens to slide on very nicely, but from past experience I have encountered a problem where it seems to go on all right, but then it can jam, just some little particles probably inside. So I used a bit, in this case, just to make sure it slides on nicely, I used a little bit of very, very fine metal sandpaper and just went over it carefully to make sure it's completely free, no obstacles whatsoever in sliding on and off. And there we are. So we're almost done. I will be putting some extra little pieces of steel, just 5mm thick or 3mm here and here, with holes for future mounting of mudguard over the wheel. Okay, that's enough. Right, I have welded the shaft that the wheel will go onto the main frame of the wheel knuckle. That little spacer there, I cut that down to 5mm thickness because I wanted that surface just there to be 8mm above the plane of the kingpin. So I pushed it down. There's some welding underneath there. I then put the washer and that and this clip on the end here just to hold that firmly in place, and then I just put some little weld for the spacer so it stays firmly in place. Okay, so that's all fine, and I then use JB weld just to go over my welding to tidy it up, make it look a little bit nicer. As you can see, it's sort of passable. It'll be painted eventually, and you can see where the heim joints will go in these positions, and there's plenty of vertical movement. I put these little tabs on here and here for the intention of mounting the wheel mud guards in the future. So it's all right. One problem is that this steel, this is stainless steel type 304, and it's very hard, and I had intended to tap a thread into the end there, but that's proved to be extremely difficult. So that's going to be modified on the end. I'm going to use I was thinking of just welding a little nut on the end, but I might do it differently. I might put a thread on, welded on with a little pin through a split pin. The trouble with a nut's all right, but ideally there should be a left-hand thread on the left side and a right-hand thread on the right side to stop the bolt from coming undone. It's not essential, but I've got a different solution with a split pin, so it's not quite finished still. This is just my lack of experience, not realizing just how difficult it is to tap a thread into, especially the 304 type stainless steel. So there we are, and it looks all right. It's passable. Finishing the video now.